Hi students, now let us see a program on quicksort, and this we are going to implement with the help of the recursion concept. Before going to see the quicksort program, let's see the theory of it. So what we do inside the quicksort is, this is also an example of divide and conquer algorithm. So already we saw another kind of the sorting, that is merge sort, is also example of the divide and conquer technique. This is also quicksort, comes under the same concept, and it was designed by the person called Tony A. year 1959. And compared to all other algorithms, this is the fastest one, and as well as this time complexity is just big O of n log n. And this algorithm is also known as partition exchange sort. So let us see how we perform the operation using this algorithm. So these are the steps we need to remember to perform the operations of sorting on the given values. So these steps are most important. So the first point here, it says that select the first or any element of the given array as a pivot element. So you can choose from the given input values any one of the element as a pivot element. Next, initialize I with the 0 index and j with the last index. So I points to the 0 index of an array, j is the last index. Next step is increment I if array of I is less than or equal to p. This condition. This should be continued continuously. Otherwise, just we have to stop the procedure. Next, fourth step is decrement the j if array of j is greater than p. Otherwise, stop it. So once we completed these third and the fourth step, during the fifth step, what we do, we have to check whether the I is less than or I is less than j or not. Then, if it is, we need to perform the swapping operation. Then, so these third, fourth, fifth steps are continuously repeated when I crosses the till I crosses the j. So once these completely 6 steps are completed, in the seventh step, we say that swap the pivot element with the pointed by j. So once this operation is completed, you can see that the elements which are less than the pivot are less than at the left side, and the values which are greater than the pivot, you can find it at the right side. So let's see these steps with the help of an example here. So this is a simple example. Along with the algorithm, we'll see another example. So this is my given input. So here I'm selecting this 3 as a pivot elements. What we need to do is, so we have to write the values less than or equal to 3 at the left side and the greater than or at the right side. So out of these given values, less than 3 are minus 3, 2, minus 6, 1, and these are the greater than the pivot element. These are less than the. Now again, out of this set and this set, we need to choose another one more element as a pivot element. So I'm just choosing this one as a pivot element. So less than 1 or minus 3, 6, greater than 1 or 2. Then again, out of this 6, I'm selecting the pivot element. So less than here, no, greater than minus 3. From here again, 6 is the pivot element. So 5 here left side, 9 and 8 are right side. Now here 8 is again I'm selecting as a pivot element. Then 8 is left side, then 9. So if you observe here, this minus 6, 3, 1, 2, 5, 6, 8, 9. How all these are values are? They are in the sorted order, sorted form. Okay. It's a simple explanation. Let's see along with the substitution of the algorithm steps. See here, these are the given my input which is not in the sorted order. Then I'm selecting this first 54 as a pivot element, and as well as I is points to the 0th location 0, 1, 2, 3, 4, 5, 6, 7, 8. So j is points to the last location value. I have to increase the I if area of I is less than or equal to pivots. 54 is less than or equal to 54. So I am moving I from here to here. Then I compare 26 and the 54. 26 is less than or equal to 54. Yes, it is the condition is the true. So you move I to here, 93. Then 93 is greater than less than or equal to 54. Condition is the false. Then you stop the procedure here. So I is placed here. Next J, 20. 20 is J is greater than pivot. No, condition is the false. So just you place the JET here. Now once these steps are over, I is less than J. I index is how much? 2, and whereas the J index is 8. 2 less than 8. This condition is the true. Then what we need to do? We have to perform the operation called swapping. So 20 comes to here and 93 goes to here. So 20 is here and 93 is here. Remaining elements you write as it is. Now again continue the process. 20 is less than and are equal to 54. Yes, condition is the true. Increase here I. Then 17. 17 is less than or equal to 54. Increase 77. 77 is less than or equal to 54. Condition is the false. You stop it here. Then J. 93 is greater than 54. Yes, you decrease the J. J comes to here. Next 55 is greater than 54. Yes, decrease the J. Then 44 is greater than 54. Condition is the false. You stop the procedure. Now again I less than J. Now you perform the swapping on this 77 and 34. So once it is over, what happens is swap 54. So 44. So then once these swap 77 and 44. So 77, 44 means 44 comes to here and 77 comes to here. So then again 44 is less than 54, increase the I, 31 is less than equal to 54, increase the I, 77. So stop it here, 77. Then 44 is 77 is greater than 54, you decrease the J. So what is happening here is I and J crossing each other. When they are crossing each other, what we need to do, we have to stop the procedure. The last step is we need to replace the pivot by the J pointed value. So J pointed value is the 31 and the pivot value is the 54. So we need to swap those two, 54 and 31. So 31 is at the first position and the 54 comes to this position. 54 is placed here. Now just you observe these values here. Now this is the my updated pivot value. If you I selected 54 pivot value. So the value is less than 54, 31, 26, 20, 77 are at the left side. Okay. So values less than 54, 31, 26, 17, 54 are at the left side. And the values greater than the 54 are at the right side. Now we have the two parts here. Now from you take the left part 31 to 44 and the right part here 77 to 93. Now again you do the same process of sorting, applying this algorithm by selecting any one of the element as a pivot element. So let's select this 44 as a pivot element, then initialize the I is here, J is here, then you continue the process. In the same way, for the right side also, you continue the process. Once the completely all operations are completed, you can find all the values in the sorted. This is how we perform with the help of the insertion sum. Okay. Now let's go to the program. See here, this is the main program. I'm asking the number of elements here. Then I'm storing those values here. Then values numbers before sort I'm displaying. Then I'm calling this quick sort by passing the 0 and the last index. And after sorting, just I'm displaying the values here. Okay. So let's see the actual code here. So let's take, just I'm taking only 3 values for the simplification array. So 0, 1, 2, my values are something 5 here, something 15 or 7, something here 4. Okay. So then array these values, left is the 0th index, right is the n minus 1, n equal to nothing but here 3 values. So here 2. So then left 0 is less than 2, condition is the true. Then I equal to left, nothing but I equal to 0, j equal to right, j equal to 2, and the p equal to left. P is nothing but a selecting the pivot value. Left is nothing but a 0, 0th location value. I'm selecting this 15 as pivot. So this condition is the true, it's okay. Now 0 less than 2, the condition is the while loop is also true. Okay, so what is happens here? Enter the while loop. So I entered a while loop. Then after that, while array of I at the 0th location, the value is 15 is less than or equal to array of t. Array of t is 15 only. So it's true, and 0 less than right. Right is nothing but a, okay. So we need to write the values of the left and right. Left equal to 0, right equal to 2. So 0 less than 2, this is condition is also true. Then what is happens? I plus plus, nothing but a I goes from here to here. So I plus plus means 1. Next, again this is the only just single statement for this file. Then array of I, nothing but a 7. 7 is less than or equal to 15, just condition is the true, and 0 I is the 1, 1 less than 2, condition is the true, I plus plus. So I value become 2, I comes to here. Next, again array of I, nothing but a 4 is less than or equal to 15, and as well as, but this condition I equal to 2, 2 less than 2, condition is the false. So just you stop the procedure here. Next you go to here. Okay. So what is the value here? Array of j. J is nothing but a 2. 2 is nothing but array of j is the 4 is greater than array of p. P is the 15. 4 is greater than 15. Condition is the false. So it doesn't execute this value. Next it comes to this condition. I less than j. So 2 less than 2, condition is the false. I value is the 2, j value is the 2. So what happens here? It doesn't perform the swapping operation. So this is the end of the if, and here there is one more loop while I less than j, 2 less than 2. So condition is the false. So that come out of that loop also. Next it goes to here. Temp equal to array of t. So temp equal to array of t means 0, that value is the 15. 15 I am storing here. Then array of p at the 0th location, array of j. Array of j means how much? J is the 2. The value second location value is the 4 that I have to store in the array of p means at the location 0. You need to store the 4 here. Okay. Then array of j equal to temp. J is how much? 2. So temp value is how much? 15. So in this place I need to store the 15. So 450. So these are swapped here. Next, once this process is completed, so I'm saying that it's a recursion concept. So what I'm doing, I'm calling the quicksort method again by passing the values of array values, and left is how much now? Left is the 0, right is instead of the right here j minus 1. J minus 1 is 2 minus 1. So 1. So 0 comma array comma 0 comma 1. Okay. So this from these two values, I go to the again quicksort. Again this all the statements will be executed. Okay. So like this, calling a function itself, it's nothing but a recursion. With the help of this recursion, I can perform remaining operations. I can sort the values using the quick sort method. Let's execute and test the values here. So enter the elements, number of elements. For example, I'm giving the 3, so 10, space 5, space 9. See number before sort 10, 5, 9. The numbers after sort 5, 9, 10. So the values are sorted here.